Measuring differentiation on increasing student interest. In many classrooms today, teachers fail to get insight on students' diverse needs and are often unaware that many students require a different method of teaching and learning. As a current special education teacher working in both resource and general education settings, a one-size-fits-all model is certainly not realistic in today's diverse classrooms. To change educational outcomes, schools and teachers need to change teaching and learning habits to engage students more within the classroom, which will ultimately increase student interest and perchance even student motivation. Certainly, no one can doubt interest has an undeniable influence on student learning. It is certainly essential to provide instruction that endeavors to capture student interest within the science classroom, or any classroom for that matter, for maximum attainment. Numerous studies have shown that students become more confident, active, and more efficient problem solvers when they are provided with practical ways of learning, like using methods of differentiation. Considering numerous definitions that attempt to explain or define what differentiation means in the classroom, the word can more readily be defined as a personalized approach intended to meet the needs of diverse learners through varied changes in content, process, product, or the learning environment. In using differentiation, teachers must use familiarity of their students to build on research-based instructional strategies that work to include various methods of differentiation, appeal to the interest of students, and are suitable for each student being taught within the classroom. When measuring differentiation on increasing student interest, I developed a hypothesis for this study. If differentiation is used in a high school science classroom in eastern Kentucky, then differentiation will resourcefully increase student interest for the benefits related to improved teaching and learning. There were two key questions related to the research. Will increasing the use of differentiated instruction strategies link to changes in students' levels of interest? And what cooperative learning strategies correspond to increased student interest as measured by participation in the science classroom? From onset, the research was strategic and completed alongside the researcher's teaching responsibilities in the science classroom. As a result of this specific variable, planning and collecting data over a period of time to investigate students' interest levels in the context of normal science lessons was both meaningful and intentional. Group of co-taught 10th, 11th, and 12th graders in integrated science served as the population for this study. By far, it was the lowest group of students compared to 5 other sections of integrated science. 5 students qualified for special education services, and the ratio of boys to girls was 13 to 7. The overall design of the research took a mixed methods approach combining both qualitative and quantitative data to explain the role differentiation imparts on engaging student interest. Student interest surveys, online surveys, and participation logs satisfy the qualitative and quantitative element of the research. The research materials consisted of a student interest survey done at onset and at the end of the research, an online survey created through Poll Everywhere that required students to use Google Chromebooks, iPhones, or tablets, and participation logs that asked for students to reflect on their learning. To begin research procedures, the student interest survey was used at onset and at the end of the research. Students were asked a series of questions that relate to personal interest in science as well as factors that make science more interesting. The surveys became an integral part of the research and were used to introduce, schedule, and implement differentiation. As another form of data collection, all students were asked to complete an interactive survey at the end of specific lessons utilizing an online approach created by the researcher through Poll Everywhere to measure student interest. The online surveys were conducted at the end of specific differentiated and traditional lessons. As a continuation of the procedures, students were asked to complete participation logs about their activity and participation for several selected lessons that involved either differentiated methods only or traditional methods only. Towards the end of the study, students' participation logs were read and reviewed as a form of observational data. During data analysis, student interest surveys provided numerical data by clarifying methods of differentiation that individual students preferred. The short online interactive surveys conducted post-lesson were used to collect data on student interest after the science lesson was completed. Participation logs were read to understand student thinking. Limitations to the research related to the debate on teacher-made surveys that could or could not prove valid and reliable to the research. Some critics might argue that teacher-made instruments do not produce reliable indicators across settings, but the purpose of the study was meant to solely measure increased student interest when differentiated methods were used. After all the data was compiled from the procedures earlier explained, results of the study concluded that differentiated learning methods used in 2 science lessons showed a percentage of students more interested in the lesson compared to a percentage of students that were less interested in the lesson. Even so, data was collected on traditional learning methods used within the science classroom. As you can see from the table, a percentage of students were less interested in the activities of traditional learning compared to those that were more interested in their traditional activities. Student-preferred cooperative learning strategies highlighted through interest surveys and participation logs included class discussions, working with peers, exploring the unknown and solving problems, using technology, conducting practical work, establishing links between topics, and engaging in hands-on activities. As the overall results confirmed, increasing the use of differentiation in science lessons within the general classroom environment positively showed improved student interest. Moreover, the use of cooperative learning lessons as a form of differentiation were useful in contributing to the overall improvement. The greatest problem possibly contended while conducting this study was student willingness to complete the interest survey with precision. It was with highest degree that students had sufficient amount of time to complete the survey to avoid rushing through each of the questions. Also, a limitation was student absence and accuracy and honesty. In the past, previous trends that inclined to interpret gaps in science interest related to gender differences between boys and girls needs further explanation. Overall, it is important that both boys and girls have the same chances to develop confidence, achievement, and interest in science through multiple means of teaching and learning. The overall foundation for increasing interest in science is to enhance students' awareness and understanding of science in everyday life, but also ensure that every student has unlimited opportunities to learn, create, and build knowledge for their future through an increased interest in science. Overall, when methods of differentiation are employed and planned effectively to improve interest, students should make reasonable and meaningful advances with regards to lasting success in science education at present and in the future.